Hey guys, so today we're going to talk about systems of linear inequalities. Um, and before we jump into actually talking about these systems of linear inequalities, I want to look back at a couple things that you guys did last week with Mr. Rimmer. Um, so my first reminder that I want to give you guys has to do with the dashed line versus the solid line. So when we're graphing inequalities, sometimes we use a dashed line and sometimes we use that solid line. And I just wanted to remind you of when we use each one of those. So the dashed line we use when something is less than or greater than, but it's not equal to. And so that dashed line really kind of represents almost like a fence. It can come right up to it, but it can't get to the dashed line. The dashed line itself is not part of the answer. Whereas the solid line indicates things that are allowed to be equal to the line. So we're still going to shade kind of above or below like you were practicing last weekend, but with the solid line, the answer or the solution can also sit on the line itself. So I might have a point sitting directly on this line that's part of the solution versus in the dash line, if there's a point on this line, it's not part of the solution. And we're going to look a little bit more at that as we move through our lesson. So let's take a look at a linear inequality. This is something similar to what you would have seen last week with Mr. Rimmer. And with Mr. Rimmer last week, we looked at this inequality down here. Y is less than 2x plus 1. And between myself and Mr. Rimmer, we talked a lot about how to graph these things. And this plus 1 represents the y-intercept. And you can see the y-intercept has been graphed right here at 1. And the 2 represents the slope, and that's 2 over 1. So from that red line, we would go up 2 and over 1, and up 2 and over 1. And we'd have these points that are all lined up. Now, what kind of line did I draw here? I drew a dashed line, and the reason I drew a dashed line was because it wasn't allowed to be equal. Finally, we need to shade one of the sides here. We're either going to shade above or below the line. And in this case, it was a less than symbol, so we chose to shade below. But I want to talk a little bit about what that means. What does it mean to shade below? And when we shade below this line, what we're really saying is that every point that we've shaded in, every single point in this area, is a solution to the original inequality. So I'm going to show you an example of that right here. This point, 2 comma 0, is in the shaded region. And if I take this 2, which is an x value, and I take this 0, which is a y value, and I plug it in to my inequality, so again, I was plugging in 2 where x was and 0 where y was, we end up, after we solve this, 0 is less than 5, and 0 is less than 5. This is a true statement. And because it's a true statement, that's why this area is shaded. If I picked another point in this shaded area, like 3 comma 1, or like 4 comma negative 4, or any other point in this shaded area, and I plugged it into my inequality, I would get a true statement out. Conversely, if I did this in the non-shaded area, so here's an example over here of a point, negative 2 comma 2. If I plugged in x is negative 2 and y is 2, I'm going to end up getting, by the time I finish simplifying all this, 2 is less than negative 3, and that's false. 2 is not less than negative 3. And that's why it's in the unshaded region, because this whole white area over here represents the things that cannot be an answer to this inequality, whereas all the shaded areas represent things that can be an answer. So now let's jump over to a system of linear inequalities. And a system of linear inequalities is very similar to what you were doing last weekend, but there's more than one inequality. So we have to meet more than one condition. So I'm going to do this couple of examples with you right now. And the first one says um, to sketch the solution to the system of inequalities. So we have y is greater than 4x minus 3, and we have y is greater than or equal to negative 2x plus 3. So we're going to start with this first equation. Y is greater than 4x minus 3. And I'm going to jump over here to GeoGebra, and I'm going to use this program to create a graph. So the equation was the inequality was y is greater than 4x minus 3. What does the minus 3 represent in this first inequality? Right, so the minus 3 represents the y-intercept, or the starting point. So if I go over to my graph, I should be able to put a point at, sorry about that, let's go back. And instead of at 3, sorry, we're going to put that at negative 3. We had a y-intercept at negative 3, and we had a slope of 4 over 1. So from that point, we're going to go up 1, 2, 3, 4 units and over 1, and up 1, 2, 3, 4 and over 1. And we're going to quickly be able to kind of draw this line in. Now, if we look back at this, it was a greater than symbol. So what kind of line should we be drawing? Right, so because it was a greater than symbol, it cannot be equal to this line. And if it can't be equal, I have to draw in a dashed line on this particular question. And once I draw my dashed line, because this is a greater than symbol, we're going to have to graph in, we're going to have to color in all the things that are above the line. So I'm going to go ahead and graph this, this line right now. This was a y is greater than 4x minus 3. And what we can see is we've got this dashed line running through my points, and we've graphed or shaded in all the things above the line here. So let's go to our other, that's our first inequality, we have to go to our other inequality as well. So we have y is greater than or equal to negative 2x plus 3. So on this question, the plus 3 is our y-intercept. So let's go back over to our graph and put a point at positive 3 this time. And our slope is negative 2 over 1. What does a slope of negative 2 over 1 mean? Right, so it means that we're going to go down 2 and over 1. So I go down 2, 1, 2, and over 1. Down 2 and over 1. Down 2 and over 1. And we start to get this linear pattern again. But this time the symbol says greater than or equal. And because of that, we're going to use a solid line instead of a dashed line. It still says greater than though, so we'll graph above that line. So let's go ahead and do that. I'm going to drop that line in now. All right, I dropped that line in. And it's shaded also above. So this line right here is solid, and we graphed in everything above. And what starts to become clear is that there's one area on this graph that was shaded in for both lines. It was part of the solution for both lines. And that is this darker blue area here, this overlapping area. The overlap represents the one area on my graph that has solutions to both of my inequalities. So while a point way out here might be an answer to one of my inequalities, or a point over here might be an answer to one of my inequalities, any point in this area that's kind of double shaded is an answer to both of the inequalities. And that makes that point, that makes this region pretty unique. By that same logic, a point that's down here where neither is shaded will be false for both of my inequalities. So really in a system of inequalities, what we're looking for is we're trying to find the area of the graph that shades to meet the requirements of both of the inequalities. All right, so let's jump back over and do one more example together. This time I'm asking you to sketch the solution to a system of inequalities that are not written in slope-intercept form. So if we look back at the last question, we had y equals mx plus b. We had a slope and an intercept. And in this question, I've given them both to you in standard form. So there's a couple different ways we could go about this, but the easiest way with system of linear inequalities is to just convert from standard form into slope-intercept form. And the way we're going to do that is we'll solve each one of these inequalities for y. We'll try to get y by itself. So I'm going to split these inequalities up. And in the first inequality, the first thing I'm going to do is I'm going to subtract by 4x on both sides. Again, we're trying to isolate y here, and y is stuck to a negative 3, which is stuck to a 4x. So we've got to get rid of that 4x in some way, and the best way to get rid of a positive 4x is simply to subtract 4x. And when we subtract 4x over here, it's because the negative 4x and the 9 are not like terms, I just kind of have to write them right next to each other. Negative 4x plus 9, and the negative 3y came straight down. What do you think the next step is in solving this equation, or this inequality for y? Cool. So the next step, yeah, is going to be to divide by negative 3. And when I divide by negative 3, we're going to end up being able to isolate y. Y is going to end up by itself. But some interesting things are going to happen. Does anyone remember what we do when we divide an inequality by a negative? Right, so when we divide by a negative in an inequality, we have to flip the inequality. So it used to say less than, and because we've divided by a negative, we're going to switch it over to a greater than sign. We're also just going to clean up these fractions a little bit. So negative 4 over negative 3, a negative over a negative is a positive 4 over 3. And then 9 divided by negative 3 is negative 3. And now I have this inequality written in a form that's a little bit easier for me to graph. Why don't you take a moment right now and try to do the same thing on the other one. See what you get when you solve for y on this inequality. All right, so let's see if you were right. This is what you should have gotten. We took away the 1x from both sides. We divided everything by 3. We didn't flip it real good because it was dividing by a positive, not a negative. And we ended up with the following inequality. All right. And now I am going to go back over to my graph. And let's graph these two inequalities. Let's graph this system. So the first one had a y-intercept of negative 3. And so we'll put that y-intercept in. And it had a slope of 4 over 3. What does a slope of 4 over 3 mean? Right, so we're going to rise 1, 2, 3, 4 and run by 3. We're going to rise 1, 2, 3, 4 and run by 3. And on this question, we have a greater than symbol, and that greater than symbol means what? Yeah, so we're going to do a dashed line through here, and we're going to graph above the line. We'll shade in above the line. And so it's going to look something like that. Nice dashed line and shading above. And on the other inequality, we've got, well, which of the following things are true on this inequality? Cool, so you should have been able to identify 4 things that are true. First of all, the y-intercept is 3, so we can drop that in there. The rate of change, or the slope, is negative 1 over 3, which means we're going to go down 1 and over 3, down 1 and over 3, etc. It's a less than symbol, which means that we're going to need a dashed line, and it's less than, which means we're going to graph below that line. And so we're going to get something that looks like that. We've got a dashed line and we're shading below. And what does the white area on this graph represent? Okay, and what about the dark blue area? What does that represent? All right, so the white area represented the area on my graph where there were no solutions. This area was not an answer to either of our inequalities, whereas the dark blue area represented an area that was a solution to both of our inequalities. So I hope that you were able to get some notes from this. I hope that some of this was kind of coming back to you as we talked about it, and you were able to make some connections to what you worked on with Mr. Rimmer last weekend. And you're going to do a little activity now where you're going to do some of this and practice some of this on your own. And as always, if you have questions about this, if anything was unclear, do feel free to reach out to Mr. Rimmer or myself. Um, we'd love for you to come in and ask questions and clarify anything that was not clear to you. So uh, best of luck. And if I haven't seen you yet, I'll see you shortly. And if I've seen you already, have a great rest of your weekend. And cool. All right. Bye.